Automotive software questions and answers. What is automotive software? Automotive software refers to the program embedded in vehicle control units. It interacts with hardware to perform real-time tasks and ensuring that vehicle system operates safely and efficiently. In modern vehicles, often 70 to 100 ECUs we had used due to the functionalities and running the millions of lines of the code. What is the difference between the ECU and microcontroller in automotive application? ECU, it talks about electronic control unit, a device that is used to control specific functions in the vehicle, such as engine management, airbag deployment, and there are some other features. An ECU may consist of multiple microcontrollers, sensors, and communication interfaces. Microcontroller, it is a small integrated circuit that contains a processor, memory, input-output interfaces, and it is used in ECUs to execute the software for controlling various vehicle functions. Explain the concept of sensor fusion in automotive embedded system. Sensor fusion involves combining data from multiple sensors to create a more accurate and comprehensive understanding of the vehicle environment. It is commonly used in ADAS driver assistance system and autonomous driving to improve the accuracy and reduce the errors. Examples, it combines data from the radar, LiDAR, camera to create a unified precision of obstacles, road conditions, and other vehicles. The benefits here improve the accuracy of environmental perception and redundancy using the multiple sensors ensure that failure of one sensor doesn't lead to the system failure. What are the challenges in developing the automotive embedded software? The real-time constraints, automotive embedded system need to meet critical timing requirements, particularly in safety critical systems like airbag and ABS. Complexity, modern vehicle contains hundreds of ECUs, each with a different software component that need to be integrated seamlessly. Safety and reliability, the safety must meet the standards ISO 262. We need to ensure that the whatever the conditions that to be operated for the real time, it should meet the standards and it should be included with the failure scenarios. Can you explain the concept of real-time operating system in automotive domain? In AUTOS is a specialized operating system that designed to ensure that tasks are completed within specific time constraints. In our automotive embedded system, the AUTOS is used to handle critical functions like brake control, engine management, and real-time sensor processing. Example of the AUTOS, free AUTOS, VxWorks. What is ISO 262 and how it affects the automotive software development? ISO 262 is the function safety standard for automotive industry that defines safety requirements for electronic system in vehicle. It provides a framework to assess risk and ensure that software is designed to avoid or mitigate the hardware hazardous failures. It standardized with the SIL, Automotive Safety Integrity Level, that defines from ASIL A to ASIL D. ASIL A talks about the least critical, ASIL D is the most critical based on the risk analysis. How would you handle the software updates in automotive system using over-the-air technology? What here the over-the-air technology software update that allow manufacturers to remotely update ECU firmware and softwares in the vehicle. This ensures that critical updates like bug fixing, security patches, and safety features can be enhanced, can be delivered without requiring a visit to the dealerships. What are the key steps? It is a preload, download. The update package is downloaded to the vehicle via the secure network connection. Validation, the vehicle verifies that integrity for the update using a digital signature or the checksum. Installation, once it verifies the update is installed on the target ECU, often during the low power state or during the non-critical vehicle uses. Rollback mechanism. In case of failure, the system should have ability to revert the previous version to maintain the functionality. What is the role of sensor fusion in autonomous vehicle? How it is related to the embedded software? Sensor fusion refers to the process of combining data from multiple sensors to create a more accurate and comprehensive understanding of the vehicle environment. What it will be the role in embedded software, where the algorithms running on ECU process sensor data identify the obstacle, landmarking, and traffic signs and pedestrians, etc. The embedded software for the sensor fusion involves filtering the calibration and processing data in real time to make a driving decision. What are the critical challenges in testing the automotive embedded software? Real-time requirement. Automotive embedded software must meet a critical strict time performance constraint. Hardware software integration ensure that software integrates correctly with the hardware, ECU and sensor actuators. Testing environment. Here the HIL hardware in loop testing simulate the real world condition by connecting the software to the real world for validation. Still, software in loop testing runs the software on simulation environment to test the algorithm before hardware deployment. Safety compliance testing for compliance with standards like ISO 262 for functional safety. How does the functional safety concept apply to the embedded automotive system? So, functional safety ensures that vehicle system perform as expected and minimize the risk that could lead the accidents and failures. So here, it defines a safety life cycle. It includes the HARA, like as a ASIL classification and verification of the safety requirements. In embedded software, safety critical functions, braking controls are designed with redundancy and file safe mechanism to ensure that they operate safely under all conditions. Explain the concept of function safety in automotive embedded. Function safety ensures that system in vehicle operation safe manner, even in the fault or failure is occurred. It is crucial in automotive system, especially in critical applications like braking, steering, and airbag system. So mainly the risk assessment, identifying the problem and ensure that the systems are designed to prevent those risks, and safety integrity level, the SIL. Here is the functional safety is defined under the SIL levels, and the fault detection and recovery. So once the problem is identified, so how that can be recovered, and the compliance to the ISO 262. This is the international standard for function safety in automotive. We need to ensure that all the safety requirements are met when we are developing the software to the respective application. How do you prioritize the task when working on automotive embedded software projects with the tight deadline? The prioritization, breaking down the task into the critical components. We need to ensure that the high priority for the safety and functional requirements are addressed first. And the tools is using the project management tool like Jira or some of the Trello to track the progress, and we need to ensure the timely completion and the team framework, collaborate with cross functional teams or the hardware engineer or the system architect to align the deadlines and deliverables. What is the difference between the embedded software and the application software? Embedded software talks about how to the software designed to control the hardware and provide the specific functionality in the embedded system. It is slightly coupled with the hardware and it optimized for the low power and memory. And application software is the software designed for end user task that runs on the general purpose computers. It is a less hardware dependency and typically has the high level of abstraction. What tools do you use for debugging automotive ML? JTAG debug for debugging the hardware level issues, accessing the processor internal registers. We use the JTAG debugger, and CAN analyzer and CANoe for analyzing the CAN traffic or debugging the CAN communication issues. Trace analysis for capturing and analyzing the runtime behavior, useful in the real-time system. And oscilloscope and logical analyzer for checking the signal integrity and timing issues at the hardware level. And JNU debugger for debugging the software and identifying the runtime errors in the embedded software. Explain the term middleware in automotive embedded software. Middleware is the software that acts as an intermediate between the application software and the hardware. It abstracts the low-level hardware detail and provides the services like communication, security, and data management to the application layer. In automotive embedded software system, the middleware is crucial for enabling the communication between the different ECUs via the communication with the CAN and LIN and Ethernet protocols for providing the functionalities such as diagnostics and over the air updates and the software downloads. Examples, the AUTOSAR middleware. This includes the communication services like the modules that handles the intra-communication, intra-ECU communication in the standardized way. What is the role of bootloader in automotive embedded software? Bootloader is a small program that runs when the ECU is powered on. It installs the hardware, verifies the integrity of the main application software using the checksums or the digital signature, and loads the application into the memory. The key role for the bootloader in the automotive embedded software is secure boot. It verifies the authentication of the software to prevent the code from the executing and update the mechanism. The bootloader may handle the auto update, allowing the ECU to load a new software version. Fallback mechanism: if the software fails, the bootloader can restore the ECU to the working state. What is the purpose of diagnostic software in automotive embedded system? Diagnostic software is used to monitor and test the functionality of various automotive systems. It allows the technician to diagnose the issue in ECUs and the other subsystem. Here the role is troubleshooting. It identifies the faults and malfunctions in the vehicle system. Fault code storage stores the diagnostic trouble code, which help in identifying the problem area. OBD, onboard diagnostic, it provides the interfaces for accessing the diagnostic information from ECUs for emission control and the system performance. Can you describe a challenging project you worked in automotive embedded system, embedded software, that how can you overcome the difficulties? Scenarios in automotive project, the task with integrating the ECU is responsible for controlling the brake system. The challenge was we need to ensure that the software meet the real-time requirement while integrating a new feature, ABS. When working with the hardware engineer to understand the constraints and dependency of the hardware and scheduling the algorithm, we need to ensure that the braking system is working on priority. After implementing the software that will be tested on the HIL platform, we are simulating with the real world conditions how that can be acted, and the result, the system passed all the safety and functional tested with the successful deployment in the vehicle. So here we need to ensure that the software that we are developed for the specific hardware, it should be integrated and it should be tested. If the hardware is not meeting with respect to the software compatibility, then the system will be filed. How do you handle the software updates in automotive embedded? So software updates in automotive embedded systems are critical for adding new features, improving the security and fixing the bugs. Here the updates must be managed carefully. We need to ensure that safety and reliability key strength over the AI updates. This method allows the software update to be delivered remotely. The update process involves downloading the new software onto the ECU, verify the integrity, and then applying the updates. Redundancy: many systems have a dual memories bank where the new software is loaded into one bank, then the other will be remains in unjail. The system can switch the update bank after verifying the new software. The file safe mechanism ensure that if the update files due to the powerless, the system can roll back to the previous known goods to the way to avoid the obstacles. And security: software update must be encrypted and signed to prevent the unauthorized updates. And version management: keep the track of different software versions and manage compatibility of the hardware. How do you ensure that combines with automotive standards such as ISO 262, ASPICE in the embedded? ISO, talks about the functional safety standards. ASPICE is the process for software development. It talks about the compliance strategy, risk management, safety requirements, and verification and validation, documentation, and process improvement. What are the challenges in integrating the automotive embedded software with hardware, and how would you address them? Challenges: hardware software integration. It should be correctly, the software should work correctly with the hardware, and the hardware should be communicated with the various ECUs, and it should have a proper communication when it is configured. And real-time constraints. So the safety criticals is the one application, and power consumption. It should be efficiently, the low power should be handled, and communication protocol. How the protocols are configured with the respect to the ECU and the solution. So we need to verify the hardware and the protocols with the different configuration on the testing part, like HIL testing and simulation and modeling and power management techniques that should be verified with the above challenges. How do you manage software versioning and configuring management in the automotive? Version controllers and with respect to the Git SVN, and there are some like other tools that can be used for code related updates and branching and merging that should be followed in the Git, and configuration management, and like that should be tracked with Jira and ClearCast and Doors. How that help we are able to manage our requirements. And tagging and releases, we should always tag the releases with the version numbers to ensure that the specific version of the software used for the testing. And the continuous integration and continuous development, CI/CD, it will be set up to automatically build, test, and deploy the software. Ensure that each change is